Hi guys, welcome again. In my previous video, I solved problems on rectilinear motion. In this video, we are going to continue solving problems on rectilinear motion using the three basic equations of motions. Okay, our first problem here says a vehicle moving with uniform velocity of 36 km per hour accelerates uniformly at 2 meters per second square until it reaches a velocity of 54 km per hour. Calculate the time taken. Okay, so first let's analyze the motion problem by beginning with our theta. Okay, a car moving with uniform velocity of 36 km per hour. So this velocity is the uniform, the initial velocity. So let's call it v now. 36 km per hour. And this is acceleration. Is 2 meters per second square. And it reaches the final velocity of 54 km per hour. So this velocity becomes our final velocity. So v, the final velocity is now equal to 54 km per hour. Okay. So let's, because in one of my videos, I tried the three basic equations of motion. So let's read this equation and see which one best suit these variables. The first one is v equal v naught plus at. S is equal to v naught t plus 1 over 2 at square. V square is equal to v naught square plus 2as. Okay, so we observe that this first equation suits this problem. And again, one thing, we are asked to find the time, so the time is unknown. So we in this to solve this motion to solve the problem, we use the first equation that says v is equal to v naught plus at, where v is the final velocity, v naught initial velocity, is the acceleration, and t is the time. And one thing we know observe here is the two velocities are in km per hour, and acceleration is in meters per second square. So to solve this problem, we convert these two velocities to meters per second. So that begins with v naught. V naught, 36 km per hour. So we are going to change this 36 km per hour to meters per second. To do that, we begin by establishing a conversion factor that says 1 km is equal to 1,000 meters, and 1 hour is equal to 3,600 seconds. Okay, so v naught is equal to 36 km per hour times 1,000 meters per 1 km times 1 hour per 3,600 seconds. Okay, so in the case, kilometer, hour cancels hour, whatever meter in second. So say v naught is equal to 36 times 1,000 meters, 36,000 meters, over 1 times 3,600 seconds equals 3,600 seconds. So let's divide 36,000 divided 3,600. There's 10 meters per second. So v naught now becomes 10 meters per second. So let's go to v, which is the final velocity. So v is equal to 54 km per hour. So we're going to use the same analysis we use to convert this 36 km per hour to meters per second. We begin with this. We say for f of 54 km per hour times 1,000 meters per 1 km times 1 hour per 3,600 seconds. Okay, so here kilometer, hour cancels hour. So whatever 54 times 1,000 meters is 54,000 meters. We say 1 times 3600 seconds equals 3600 seconds. So to find this, say V is now equal to 54,000 divided 3600. 15 meters per second. Okay. So now we come out to our equation that says V is equal to V naught plus AT. And in this equation, we want to find T, which is the time. We have V value, have V naught value, have A value. So let's replace them. V is 15 meters per second which represents the 54 kilometers per hour. 15 meters per second is equal to the V naught is 10 meters per second, which represents 36 kilometers per hour. A is 2 meters per second square. 1 T. Let's continue here. So we say 15 minus 10 gives us 5 is equal to 2t. 2t. So you want to find t. So divide both sides of the equation by 2. 2. 5 divided by 2 gives us 2.5 equal to t. And the name of the time is seconds. So therefore t is equal to 2.5 seconds. So the time the vehicle takes to perform the motion is 2.5 seconds. Let's look at another problem again. Okay. This is the next problem. It says a man increased his speed by 6 meters per second after 22 seconds if his initial velocity was 20 meters per second. Calculate the average distance covered if his speed was at uniform acceleration. Alright, so to solve this motion problem, begin by setting our theta. Okay, the question says the man increased his speed by 6 meters per second after 22 seconds if his initial velocity was 20 meters per second. So the initial velocity V naught is 20 meters per second. So the final velocity is increased by 6 meters per second. So the final velocity will be 6 plus 22, 6 plus 20, which gives us 26 meters per second. To the final velocity. We are asked to calculate the average distance traveled by this man. So the time here is 22 seconds. 22 seconds. So the distance S is unknown. Alright. So whenever we're asked to find the average distance, in here we have two velocities. You know, normally the distance is equal to the velocity multiplied by time. And yes, so we have two velocities, we'll find the average of these two velocities. Will be S equal V plus V naught over 2 multiplied by T. So this is the equation we use to solve this problem. Say S is equal to the initial velocity is 20 meters per second. The final is 26 meters per second. All over 2 times T, and T is 30 seconds. Alright, so say S is equal to 20 plus 26 gives us 46 over 2 by 30 seconds. So S is equal to 26, 46 by 2 gives us 23 per second times 30 seconds. So let's do our multiplication. 26 times 30. 23 times 30. It gives us 690. So this is the distance travel. Thanks for watching this video. Please subscribe to this channel for more amazing videos. This video is intended for wide students mainly. Thanks for watching again.